So welcome to 50 Shades of Error. I think this is the first time in 2-3 years that I'm giving a talk which is not about languages, Erlang LS, ELP, IDEs. So if you're there, if you're here because of that reason, I'm sorry to disappoint you. This is something completely unrelated, different. It feels refreshing. So who am I? I'm Roberto. I'm a software engineer at WhatsApp. I work in a team called WhatsApp Developer Infrastructure. I've been there for about 4 years now. Together with my team, we are responsible for the Erlang developer experience at WhatsApp. As you may know, WhatsApp, the vast majority of the WhatsApp server code base is implemented in Erlang. So we have many Erlang developers, and we want to keep them happy so they can ship features. Since most of the work that we do is not specific to WhatsApp in any way, but it's generic to Erlang, we tend to open source as much as we can, and this is an example. But enough talking, let's look at some code. So here is a very minimal Erlang module. It's called codebeam Europe 2025, and we have a single exported function, a equals b. We call two functions, a and b. They return some maps, and then we use an assertions to verify if they are the same or not. Let's assume this is part of a rebar project. Rebar 3 is like a standard build tool for Erlang. So we go to the terminal, we run rebar 3 shell, and we try to execute the exported function. So we say codebeam Europe 2025, a equals b. What do you expect to happen? An exception. After all, the talk is called like 50 Shades of Error, so an error, right? So we get an exception. The assertion is quite simple. It says that assert equal failed on a module, which is called codebeam, on line 10, where the expression b was expected to have some value, and it has a different value. Kind of works. The two maps, the two data structures we use are as small as possible to fit in a slide and still be readable. You can imagine, I think, people in this room who have been writing Erlang for a while, you may end up with the huge maps and huge data structures, which are kind of hard to compare. But I mean, we see they're different, and we can investigate why. So we take the same module, and we do a little change. There is one thing in this slide which is different from the previous one. Can anyone tell what it is? Sorry? The maps are the same, or like they are unchanged between the slides. There is one thing. We are including the assert.hrl file, not from the standard lib, which is an application which comes with Erlang OTP, but from something else called assert. The rest of the code is the same. So we go back to the terminal, we run rebar 3 shell. What happens? Another error, but this time is a different kind. Like, we cannot even compile the code because we are saying like, well, I mean, like, you are including this header file from assert, and standard lib is something that we knew about. It comes with Erlang OTP, but what is this thing? What is assert? Well, that's because I cheated, so we need two changes. If this is a rebar config, a rebar project, we need to add assert as a dependency for our project. So we go to the rebar config, we add assert in the dependencies, and that's it. We go back to the terminal, we compile, this time it works. We get access to the shell, we execute this function. What do you expect? Right, it's still an error, but it comes with colors. So this might not look like a small, it might look like a very small thing for many developers, but it's something that I really, really longed for a long time, especially when you have a big map or a big data structure, or you're looking at a huge binary and you don't know what's there. So is this a new thing? No. Elixir had it since 2016. And in our team, we have one person, Mihao Muskawa, who was part of the Elixir community for a long time, and he's been complaining about lack of this in Erlang for a very long time. So I decided to start a little side project and implement this. So Elixir had it since 2016. Now Erlang has it too. And it's available on GitHub. It's open source. There is a README that covers basically what I cover in this talk. It's available on Hex, so you can just use it. It's a drop-in replacement for stdlib assert. How does it work behind the scenes? As I said, it's inspired from Elixir. It's basically a port of an existing library. The diffing algorithm that we use to compare text is based on Zotonic diffy is a dependency. It's another repository is available on GitHub. And the actual algorithm it uses is from Neil Fraser's diff match and patch. It's not very relevant. It just we use it for the purpose of diffing things. I believe the original algorithm was implemented at Google in the context of Google Docs. On top of that, we do something that is called structural diffing. So essentially, we use the Zotonic diffy library to highlight, to understand what is different. And then in the library, we kind of know the data types that we have. So tuples, maps, and so on, so that whenever we find the data structure which is different, we can go inside the data structure and say compare keys and values and so on. And we do other nice things like, for example, pretty printing of records, so that if you have two records and you compare them and they are different, you don't see the tuple representation, you actually see the names and the fields which are different, and a few other things. One that I'm not going to cover, for example, in assert match, one feature that I was really missing is when you have an assert match, not an assert equal, you get the value that you are expected to have, but you don't, the value, yes, but you don't get the current bindings at that point. So you don't know what you're comparing with. So you have to go back to the code and check. Now we extract the values and we print it. So you say, this is assert match is failing because 24 is different from 42. Then we have something else, which is implemented as part of the library, and it's called exception blaming. I'll explain what it is with an example, but essentially it's a way to enhance the stack trace for errors and to get more information. Again, exception blaming is not a new idea. If you come from Elixir, you had it since 2017, so 1 year after. And again, it was Mihao that was complaining about why don't we have this? So what is exception blaming? Let's look at another very simple module. It's called exception blame. It has a single function, a single exported function, main with arity1, so one single argument. The function has 4 clauses. Each clause doesn't do anything particularly interesting. The point is that we have multiple clauses, and each clause has some arguments and some guards. We compile this code. We go to the terminal, rebar3 shell, we execute, and we call the exception blame main with a single tuple of 3 elements. What happens? An exception, an error. But the error is not particularly useful, right? We get no function clause matching exception blame main. We have information about the input that we give to the function. So the next action that we take as developers is to go back to the code and check and figure out why each clause didn't match. So you have to do this manually all the time. Let's try to wrap our exception blame main into a try-catch. So we will catch this exception. If we catch this exception, we call another function. We call this blame, format blame, blah. Essentially, we take the existing stack trace and we format it in a nicer way. This is what you get now. The colors are actually what you get in the terminal. So we don't just say that we get a function clause. I omitted you get the original exception anyway. So yes, there was not function clause, but you actually see why the function is not that each clause is not matching. So this is Erlang, so we start from top. The input is at the top, right? The tuple with 3 elements. The integer 1, the empty list, the integer 1. We go to the first clause, and we say, this is a tuple with 2 elements. That's a different shape, so we cannot match. We need to move. Go to the second clause, same reason. We go to the third clause. This time, we match against a pattern which has the same shape. It's a tuple with 3 elements, so we start evaluating the guards. So, is the first element an integer? Yes. Is the second element an integer? No. So, maybe this was a typo. Maybe you pass a different argument. Maybe you mistyped the guard. But in my experience, this makes like a lot of different when you're troubleshooting a real code. Again, this is a toy example, but imagine you have a gen server like a handle call with many, many clauses and very complicated patterns. So in this example, we wrapped our function in a try-catch. Does it mean that we have to like annotate like all our code with the try-catches? Not really, otherwise nobody would ever use this. So we need this thing to be somehow integrated with build tools. At WhatsApp, we use Bug2 for building our tool. It's something developed at Meta or Facebook. And it has integration for Erlang. That's what we use. If you look inside Bug2, you have some Erlang rules. We support common test, and there is a module which handles like common test error printing. So we already added support in Bug for exception blaming. Essentially, you can configure an environment variable and say, I want exception blaming for common test errors. And this will basically do the try-catch for you. But obviously, I think outside of WhatsApp, I don't expect many people to use Bug2 in combination with Erlang. So most people will probably use Reaper 3. And for Reaper 3, the integration is to be done. The main reason is that the library was not yet open source, so it would be very weird to add an integration to Reaper for something that was not available. But now the library is open source, so it's possible. There is already a module for pretty printing stack traces for common test and EXUnit and all the other stuff. So if you're looking for a very nice, impactful contribution for the community, this is excellent. But it should be fairly trivial. Like you essentially call like wrap a function with a try-catch and call blame. So how does this work behind the scenes? This is a bit more complicated, right? Compared to adding some colors. Again, is inspired by Elixirs and the exception blame. It relies on a parse transformation. And I see like people like screaming in horror and leaving. So when you actually look for parse transformation in the Erlang OTP documentation, I can imagine like someone sitting at Ericsson very angry and saying like, programmers are strongly advised not to engage in parse transformations. No support is offered for problems encountered. Challenge accepted. So we use a parse transformation. We are not Elixir, so there is nothing else really that we can do to get this. So how does this work? Essentially, we rely on some markers that is part of the macros, and then we expand them. We need to read the AST, like the syntax tree, to extract the function clauses that you have. That means that the code that we need to annotate needs to be compiled with debug information, which is usually fine because this is for a testing library. It's not something that you would use in production. So it usually is OK to assume that you have debug info. Then we use the Erlang evaluator, like erleval, that comes with Erlang OTP, to evaluate the actual argument that you're passing with the various patterns. We also have a dependency on a project which is called erlfmt, is a formatter for Erlang. The reason why we have this dependency is because we use the erlfmt algebra module for manipulating the document and pretty printing and doing a lot of stuff that we didn't want to repeat. And in Erlang OTP, I don't know if you're aware, but when you raise exceptions, you have a mechanism. If you go to the Erl error documentation, you can see how it works. But essentially, you can annotate your exceptions with an error info map, and then you can implement that format error callback function. And that allows you to customize the way you print stack traces. So that's what we use. Please do never ever use this in production. We are also considering adding a linter in the ELP language server to like avoid that people start using these things in production, because this is like just evil, like uses parse transformation, evaluate code, could have side effects. Like it's not something that you really want to use. It's only for testing. So if you have common test suite and the test case is failing, you get a much better experience. What is left? And here is where contributions are more than welcome. So right now we only support function clause for exception blaming, but it should be like fairly straightforward to add other types of errors, so that we can do. Diffing is suboptimal in some cases. For example, we may be able to diff like very specific things, and instead we highlight like a bigger section, which is still good enough. Or if you have a huge map or a huge data structure, it's nice to have in color, but maybe another approach would be to just collapse all the irrelevant parts with like ... and then only see the difference. We have a few bugs, minor bugs that we need to fix. The good thing is that if there is a bug, it usually defaults to the regular exception, so you don't get colors, you don't get the extra information, but it still like functions. Integration with Rebirth 3. And maybe one day this thing could just be integrated with Erlang OTP or inspire a better version, because I think everyone would benefit from having this kind of features. Shameless plug. A month or so ago, I created a YouTube channel. It's called Erlang Dev. The idea is to post there like small videos, like 5-10 minutes, about tools and libraries. So I'm going to upload a assert tutorial on how to basically like a shorter version of this, more practical, so that people know how to add assert to their project and use it. Project is available on GitHub under What's Up. It's called Assert, and on Hex. So that's all I had for today. Thank you.
Thank you very much, Roberto. That was cool. Questions? There are questions. Go here. I don't know who came first, but yeah.
Very practical ones. Does it need any OTP version? Like it works for any OTP versions, or it's like 26, 27, something like that?
I developed this like last year. So it's completed from at least 1 year ago, so I don't expect
27 plus something like that.
Probably 26 or 27, yeah.
And does it need the new terminal, the new shell? No, it's for whatever. No. And how does it work with common test HTML output? If you use assert on your common test and you want to check the HTML, does it have the colors there, or will it blow up?
We have our own like infrastructure, so I would need to check, but that's like we can fix it if it doesn't work. Cool. Essentially, the output, like the wrappers, you can customize them. So even if it doesn't work with colors and dark mode
we can
whatnot,
turn those characters into HTML, and that's fine.
Yes.
Thank you.
Them.
Thank you very much. I have another question. At least the part that seemed simpler, the assert part, why not contributing to OTP, assert header file?
Because like we also have evil things in there. For example, the assert match as a parse transformation.
Okay.
That's how we extract variables. So that's why it needs...
maybe still parts of it could be contributed and everybody, I don't know.
Yeah, I think we need to.
Sounds fun. Thank you.
Yeah, it's a little project, so I think the main thing is that throw the idea out there, and hopefully someone from the OTP team can like take it.
There's one more here.
Yeah. Why do you need a parse transform in the first place? There's not enough information in the debug info chunk.
Sorry.
Why do you need the parse transform, for example, for the assert?
So for the parse transformation in assert matches, because you want to extract the variables, and you need that information is not available. Like if you see a regular, like maybe I have it. Yeah, it's complicated. I have a hidden slide for this, but you have like the parse transformation is, for example, in the blame. Like you want to extract, like take the code and you replace the code with something else, so that like you actually execute the code and you evaluate and you see the patterns and you see where it fails. And in the assert match, we use it to extract the values of you change the code so you can display the actual values that you have and the expectations in that. No, like you also need yeah, you need to use like the syntax lib libraries to extract the that you annotate bindings.